All right. Hello. It's evening now. It's like basically almost midnight, but I don't really care. Today is my day 2 for 100 days of code, so regardless of what time I'm here, I had to be here. So, I don't have like a huge amount of time today just because it is kind of late, but I definitely want to put my hour in at the very least. And so, um, I kind of already have my tab open for the fast.ai course, which is the first course that I'm starting out with. I think that there is a few things I'm going to have to set up today just to make sure that I can do the different exercises throughout this course. So, they do mention like a lot of the stuff is going to be using Kaggle, and then also Paperspace for training, which I think I have an old Paperspace account, but it's been a minute. So, um, I am going to make sure those are set up. And then yesterday, I didn't try very hard, but I wasn't able to run my Jupyter notebook in VS Code. So I'm I might have to set some stuff up. I probably don't, but it might have just been a package wasn't installed for me. But in my um, in my Python environment. But either way, a few of those things I might have to do today. So I'm kind of focused on making sure that happens. And I'm proud to say I actually made it to YouTube as well this time because yesterday I realized for some reason the wrong YouTube account was connected. So I was live on YouTube, but I was on like my gaming channel, which was not my intention. So I did rebroadcast the stream from yesterday on YouTube earlier today. Uh, and but this is like live in both places, so I'm excited about that. Um, so after the fact, basically all of my stream VODs, they live on Twitch for a little bit of time, but then eventually they get deleted. But all of the full 100 days of code will be on YouTube. And I'm trying to push a little bit more towards spending more time on YouTube. Y'all know that. So if you're new or here from YouTube, welcome. Let me know. I don't know if I have the um, chat's fully integrated. So I do have chat that comes on screen, but most of the time, oh, I guess I can see some of it is coming from YouTube as well. So, okay, so it looks like the chat on screen is coming from both sources. And I do have both chats up so I can just like keep track. But overall, yeah, baby boy finally went to sleep. He was up for a minute. So I wanted to finish. I wanted to get like some work done after he went to bed. So hence it's kind of late for me. But yeah, so I got a good solid hour. That's like I don't know where my counting was yesterday. I said something crazy like 4 palms or 3 palms or something. An hour is really only like 2 palms. So I'm going to get 2 palms in. My palms will be 25 minutes. Um, with a little bit of a break in between, give or take. So that should take me about an hour. So I will go back and forth between. Actually, this lesson is pretty long. So I'm just gonna pick up on this one, and I'm just gonna focus on getting lesson one done tonight. So I think that gives me something to target and aim at. So yeah. Let's see. So I will dial down on the music. And let's pick up where we left off with this
Welcome
material.
to Practical Deep Learning for Coders Lesson 1. This is version 5 of this course, and it's the first new one we've done in 2 years, so we've got a lot of cool things to cover. It's amazing how much has changed. Here is a XKCD from the end of 2015. Who here has seen XKCD comics before?
I forgot
Pretty
my
much
palm.
everybody, not
Hold on.
surprising. So the basic joke here is, I'll let you read it, and then I'll come back to it.
There we go. So the browser is gonna give me a notification automatically when my 25 minutes is up.
So it can be hard to tell what's easy and what's nearly impossible. And in 2015, or at the end of 2015, the idea of checking whether something is a photo of a bird was considered nearly impossible. So impossible, it was the basic idea of a joke, because everybody knows that that's nearly impossible. We're now going to build exactly that system for free in about 2 minutes. So let's build an is it a bird system. So we're going to use Python. And so I'm going to run through this really quickly. You're not expected to run through it with me because we're going to come back to it. Okay. But let's go ahead and run that cell. Okay. So what we're doing is we're searching DuckDuckGo for images of bird photos. And we're just going to grab one. And so here is the URL of the bird that we grabbed. Okay, we'll download it. Okay, so there it is. So we've grabbed a bird, and so, okay, we've now got something that can download pictures of birds. Now, we're going to need to build a system that can recognize things that are birds versus things that aren't birds from photos. Now, of course, computers need numbers to work with, but luckily, images are made of numbers. I actually found this really nice website called PixSpy, where I can grab a bird, and if I wiggle over it, let's pick its beak, you'll see here that that part of the beak was 251 brightness of red, 48 of green, and 21 of blue. So that's RGB. And so you can see as I wave around, those colors are changing, those numbers. And so this, this picture, the thing that we recognize as a picture, is actually 256 by 171 by 3 numbers between 0 and 255, representing the amount of red, green, and blue on each pixel. So that's going to be an input to our program that's going to try and figure out whether this is a picture of a bird or not. Okay, so let's go ahead and run this cell, which is going to go through, and I needed bird and non-bird, but you can't really search Google Images or DuckDuckGo images for not a bird. This doesn't work that way. So I just decided to use forest. I thought, okay, pictures of forest versus pictures of bird sounds like a good starting point. So I go through each of forest and bird, and I search for forest photo and bird photo, download images, and then resize them to being no bigger than 400 pixels on a side, just because we don't need particularly big ones. It takes a surprisingly large amount of time just for a computer to open an image. Okay, so we've now got 200 of each. I find when I download images, I often get a few broken ones, and if you try and train a model with broken images, it will not work. So here's something which just verifies each image and unlinks, so deletes the ones that don't work. Okay, so now we can create what's called a data block. So after I run this cell, you'll see that I'll go through the details of this later, but a data block gives fast.ai, the library, all the information it needs to create a computer vision model. And so in this case, we're basically telling it, get all the image files that we just downloaded. And then we say, show me a few, up to 6. And let's see, yeah, so we've got some birds, forest, bird, forest. Okay, so one of the nice things about doing computer vision models is it's really easy to check your data because you can just look at it, which is not the case for a lot of kinds of models. Okay, so we've now downloaded 200 pictures of birds, 200 pictures of forests. So we'll now press run. And this model's actually running on my laptop. So this is not using a vast data center. It's running on my presentation laptop, and it's doing it at the same time as my laptop is streaming video, which is possibly a bad idea. And so what it's going to do is it's going to run through every photo out of those 400. And for the ones that are forest, it's going to learn a bit more about what forest looks like. And for the ones that are bird, it'll learn a bit more about what bird looks like. So overall, it took under 30 seconds. And believe it or not, that's enough to finish doing the thing which was in that XKCD comic. Let's check by passing in that bird that we downloaded at the start. This is a bird. Probability it's a bird, 1. Rounded to the nearest 4 decimal places. So something pretty extraordinary has happened since late 2015, which is literally something that has gone from so impossible it's a joke to so easy that I can run it on my laptop computer in, I don't know how long it was, about 2 minutes. And so hopefully that gives you a sense that creating really interesting, real working programs with deep learning is something that it doesn't take a lot of code, didn't take any math, didn't take more than my laptop computer. It's pretty accessible, in fact. So that's really what we're going to be learning about over the next 7 weeks. So where have we got to now with deep learning? Well, it moves so fast, but even in the last few weeks, we've taken it up another notch as a community. You might have seen that something called DALL-E 2 has been released, which uses deep learning to generate new pictures. And I thought this was an amazing thing that this guy, Nick, did, where he took his friend's Twitter bios
And this is
and
like
typed them into the
this is
DALL-E
the end of the
2
year. This
input,
is from
and it generated
2020.
these pictures.
So
So this guy's, he typed in
so I
commitment,
mean, even
sympathetic,
since then, so
psychedelic,
much stuff
philosophical,
has
and it generated
happened.
these pictures. So I'll just show you a few of these. I'll let you read them. I love that.
So now we got Dolly and Mid
That one's
Journey
pretty amazing, I reckon.
and a lot
Actually,
of open source models too, which is something I'm interested in getting into more.
I love this. Happy Sisyphus has actually got a happy rock to move around. So this is like, yeah, I don't know. When I look at these, I still get pretty blown away that this is a computer algorithm using nothing but this text input to generate these arbitrary pictures, in this case of fairly, complex and creative things. So the guy who made those points out, this is like, he spends about 2 minutes or so, creating each of these. Like he tries a few different prompts and he tries a few different pictures, and so he's given an example here of like when he types something into the system, like here's an example of like 10 different things he gets back when he puts in expressive painting of a man shining rays of justice and transparency on a blue bird Twitter logo. So it's not just, DALL-E 2, to be clear. There's, a lot of different systems doing something like this now. There's something called Midjourney, which this Twitter account posted a female scientist with a laptop writing code in a symbolic, meaningful, and vibrant style. This one here is an HD photo of a rare psychedelic pink elephant. And this one, I think, is the second one here. I never know how to actually pronounce this. This one's pretty cool. A blind bat with big sunglasses holding a walking stick in its hand. And so when actual artists, so this, for example, this guy said he knows nothing about art. He's got no artistic talent. It's just something, he threw together. This guy is an artist who actually writes his own software based on deep learning and spends, months on building stuff. And as you can see, you can really take it to the next level. It's been really great actually to see how a lot of fast.ai alumni with backgrounds as artists have gone on to bring deep learning and art together, and it's a very exciting direction. And it's not just images, to be clear. Another interesting thing that's popped up in the last couple of weeks is Google's Pathways language model, um, which can take any arbitrary English as text question and can create an answer which not only answers the question, but also explains its thinking, whatever it means for a language model to be thinking. One of the ones I found pretty amazing was that it can explain a joke. I'll let you read this.
Okay, I wanted to look and see if I have that this blog on my list. I do follow like the Google
So
research blog.
this is actually a joke that probably needs explanations for anybody who's not familiar with TPUs. So this model just took the text as input and created this text as output. And so you can see, again, deep learning models doing things which I think very few, if any of us, would have believed would be maybe possible to do by computers even in our lifetime. This means that there is a lot of practical and ethical considerations. We will touch on them during this course, but can't possibly hope to do them justice. So I would certainly encourage you to check out ethics.fast.ai to see our whole data ethics course taught by my co-founder, Dr. Rachel Thomas, which goes into these issues in a lot more detail. All right. So, as well as being an AI researcher at the University of Queensland and fast.ai, I am also a homeschooling primary.
I was going to skip ahead because I know that he was
now
using
because
that
there's not enough of you to shout out to Radek. Radek created cups.fast.ai for me. I said to him last week, I need a way of seeing colored cups on the internet. And he wrote it in one evening. Very different about this course. Very different about this course. Nothing would be better than checking out Radek's work, and he's actually written a book about his journey. It's got a lot of tips in particular about how to take advantage of fast AI, make the most of these lessons. And so I would certainly say check that out as well. And if you're here live, he's one of our TAs as well, so you can say hello to him afterwards. He looks exactly like this picture here. So I mentioned I'm spent a lot of time studying education, both for my homeschooling duties and also for my courses. And you'll see that there's something a bit different, very different about this course, which is that we started by training a model. We didn't start by doing a in-depth review of linear algebra and calculus. That's because two of my favorite writers and researchers on education, Paul Lockhart and David Perkins, and many others, talk about how much better people learn when they learn with a context in place. So the way
oh
we
my
learn
God,
math
this is literally
at
me. I
school,
talk
where
about
we
this
do
all the
like
time, all the time.
counting and then adding and then fractions and then decimals and then blah, blah, blah. And, 15 years later, we start doing the really interesting stuff at grad school. That is not the way most people learn effectively. The way most people learn effectively is from the way we teach sports, for example, where we show you a whole game of sports. We show you how much fun it is. You go and start playing sports, simple versions of them. You're not very good, right? And then you gradually put more and more pieces together. So that's how we do deep learning. You will go into as much depth as the most sophisticated, technically detailed classes you'll find later, right? But first, you'll learn to be very, very good at actually building and deploying models. And you will learn why and how things work as you need to get to the next level. For those of you that have spent a lot of time in technical education, like if you've done a PhD or something, will find this deeply uncomfortable because you'll be wanting to understand why everything works from the start. Just do your best to go along with it. Those of you who haven't will find this very natural.
I really do prefer to know a lot of theory, but I know it's like just so much more useful to have context first. And that's the approach I'm taking for this journey overall.
Educational research literature scattered through this course. On the whole, I won't call them out. They'll just be there. But maybe from time to time, we'll talk about them. All right. So before we start talking about how we actually built that model and how it works, I guess I should convince you that I'm worth listening to. I'll try to do that reasonably quickly because I don't like tooting my own horn, but I know it's important. So the first thing I mentioned about me is that me and my friend Sylvain wrote this extremely popular book, Deep Learning for Coders, and that book is what this course is quite heavily based on. We're not going to be using any material from the book directly, and you might be surprised by that. But the reason actually is that the educational research literature shows that people learn things best when they hear the same thing in multiple different ways. So I want you to read the book, and you'll also see the same information presented in a different way in these videos. So one of the bits of homework after each lesson will be to read a chapter of the book. A lot of people like the book. Peter Norvig, Director of Research, loves the book. In fact, his one's here. One of the best sources for a programmer to become proficient in deep learning. Eric Topol loves the book. Hal Varian, Emeritus Professor at Berkeley, Chief Economist at Google, likes the book. Jerome Pacenti, who is the head of AI at Facebook, likes the book. A lot of people like the book. So hopefully you'll find that you like this material as well. I've spent about 30 years of my life working in and around machine learning, including building a number of companies that relied on it, and became the highest ranked competitor in the world on Kaggle in machine learning competitions. My company, Inlytic, which I founded, was the first company to specialize in deep learning for medicine. And MIT voted it one of the 50 smartest companies in 2016, just above Facebook and SpaceX. I started fast.ai with Rachel Thomas, and that was quite a few years ago now, but it's had a big impact on the world already, including work we've done with our students has been globally recognized, such as our win in the Dawn Bench competition, which showed how we could train big neural networks faster than anybody in the world and cheaper than anybody in the world. And so that was a really big step in 2018, which actually made a big difference. Google started using our special approaches in their models. NVIDIA started optimizing their stuff using our approaches. So it made quite a big difference there. I'm the
This is
inventor of the
another book
ULM
I
fit
want to
algorithm,
read
which
as
according
well.
to the Transformers book was one of the two key foundations behind the modern NLP revolution. This is the paper here. And actually, interesting point about that, it was actually invented for a fast AI course. So the first time it appeared was not actually in the journal, but it was actually in lesson 4 of the course. I think the 2016 course, if I remember correctly. And, most importantly, of course, I've been teaching this course since version 1. And this is actually, I think this is the very first version of it, which even back then was getting HBR's attention. A lot of people have been watching the course, and it's been, really widely used. YouTube doesn't show likes anymore, so I have to show you our likes for you. It's been amazing to see how many alumni have gone from this to really doing amazing things, and so, for example, Andre Karpathy told me that at Tesla, I think he said pretty much everybody who joins Tesla in AI is meant to do this course. I believe at OpenAI,
What
they
the
told me
heck?
that all the residents joining there first do this course. So this course is really widely used in industry and research for people, and they have a lot of success. Okay, so there's a
I
bit
don't know
of
why I
brief
went black
information
there,
about
but
why you should hopefully keep going with this. All right, so let's get back to what's happened here. Why are we able to create a bird recognizer in a minute or two? And why couldn't we do it before? So I'm going to go back to 2012. And in 2012, this was how image recognition was done. This is the computational pathologist. It was a project done at Stanford. Very successful, very famous project that was looking at the 5-year survival of breast cancer patients by looking at their histopathology images slides. Now, so this is like what I would call a classic machine learning approach. And I spoke to the senior author of this, Daphne Koller, and I asked her why they didn't use deep learning. And she said, well, it wasn't really on the radar at that point. So this is like a pre-deep learning approach. And so the way they did this was they got a big team of mathematicians and computer scientists and pathologists and so forth to get together and build these ideas for features like relationships between epithelial nuclear neighbors. Thousands and thousands, actually, they created of features, and each one required a lot of expertise from a cross-disciplinary group of experts at Stanford. So this project took years, and a lot of people, and a lot of code, and a lot of math. And then once they had all these features, they then fed them into a machine learning model, in this case, logistic regression, to predict survival. As I say, it was very successful, right? But it's not something that I could create for you in a minute at the start of a course. The difference with neural networks is neural networks don't require us to build these features. They build them for us. And so what actually happened was in, I think it was 2015, Matt Zeiler and Rob Fergus took a trained neural network and they looked inside it to see what it had learned. So we don't give it features, we ask it to learn features. So when Zeiler and Fergus looked inside a neural network, they looked at the actual the weights in the model and they drew a picture of them. And this was 9 of the sets of weights they found. And this set of weights, for example, finds diagonal edges. This set of weights finds yellow to blue gradients. And this set of weights finds red to green gradients, and so forth, right? And then down here are examples of some bits of photos which closely matched, for example, this feature detector. And deep learning is deep because we can then take these features and combine them to create more advanced features. So these are some layer 2 features. So there's a feature, for example, that finds corners, and a feature that finds curves, and a feature that finds circles. And here are some examples of bits of pictures that the circle finder found. And so remember, with a neural net, which is the basic function used in deep learning, we don't have to hand code any of these or come up with any of these ideas. You just start with actually a random neural network and you feed it examples and you have it learn to recognize things. And it turns out that these are the things that it creates for itself. So you can then combine these features. And when you combine these features, it creates a feature detector, for example, that finds kind of repeating geometric shapes. And it creates a feature detector, for example, that finds kind of frilly little things, which it looks like is finding the edges of flowers. And this feature detector here seems to be finding words. And so the deeper you get, the more sophisticated the features it can find are. And so you can imagine that trying to code these things by hand would be, insanely difficult, and you wouldn't know even what to encode by hand, right? So what we're going to learn is how neural networks do this automatically, right? But this is the key difference of why we can now do things that previously we just didn't even conceive of as possible, because now we don't have to hand code the features we look for. They can all be learned. Now, it's important to recognize we're going to be spending some time learning about building image-based algorithms. And image-based algorithms are not just for images. And in fact, this is going to be a general theme. We're going to show you some foundational techniques, but with creativity, these foundational techniques can be used very widely. So for example, an image recognizer can also be used to classify sounds. So this was an example from one of our students who posted on the forum and said for their project, they would try classifying sounds. And so they basically took sounds and created pictures from their waveforms. And then they used an image recognizer on that. And they got a state-of-the-art result, by the way. Another of our students on the forum said that they did something very similar to take time series and turn them into pictures and then use image classifiers. Another of our students created pictures from mouse movements from users of a computer system. So the clicks became dots and the movements became lines and the speed of the movement became colors.
Okay, my my palms up, my palms up. I want to start my break. Put the music back on for a second. I was really excited when I was reading or like kind of following a little bit more about this course yesterday. Just because, first of all, two things. When he was talking about the top-down approach to learning, that's something that I've also found is really, really, really useful. And one of my biggest pet peeves with technical education, especially like in academia. I mean, it makes sense, you know, we teach things from theory up, but at the same time, I feel like that contributes a lot to how much people decide whether or not they want to pursue, you know, computer science or other like engineering STEM fields in the long run. Because it's kind of hard when you don't have anything to connect the knowledge that you're learning to. And then he talked about the top down learning, and he also talked about, there was one more thing. Oh, he said if you want to, like, one way to learn something well is to digest it from different sources. And I always talk about this because I learned this when I was actually taking my Java boot camp. Like, I think it was 2016. Yeah, I think it was 2016. So when I was taking my boot camp, mind you, even back then, I already had experience with programming. Like I was freelancing as a front end developer at the time, but I wanted to branch out, and I also felt like I wanted a little bit more um, foundation, and I just didn't feel like I wasn't giving it as much time as I needed to. So I ended up taking the boot camp, and even though I already knew how to program, like I still was trying to get a lot out of my boot camp, and I was trying to really like, you know, digest all the information. So what I would do is during the day, obviously I was in class. I went to a full-time program, so 9 to 5 type of situation. So during the day, I would, you know, listen to the lectures, quote unquote, given that my instructor gave us. And then in the afternoons, we would work on labs. And then when I would go home, I had two additional resources for learning. So during the day, I had my lectures. And then when I went home, I would use a YouTube channel and Treehouse. I used to use Team Treehouse. I haven't used Treehouse in a little bit, but I literally probably like last year stopped maintaining my Treehouse subscription. I had that for so many years. So, what I would do is, like I said, I would have my lecture during the day. Then at night, I would go home, and whatever was the topic of the lecture, like say if it was like polymorphism, okay, I would listen about polymorphism, take my notes and stuff, and try to work through my lab as best I could. Then I would go home and watch a YouTube video about polymorphism in Java. And I had a specific channel I used to like to watch back then because I was looking at like Java in particular. So it was a specific channel I used to watch. So then that would be my second resource, and then my third resource would be Treehouse. So then I would go, because like Treehouse had Java curriculum back then too. So then I would go and look up polymorphism again on a Treehouse workshop, and I will work through materials that way, and that really helped me learn a lot of concepts that didn't click at first, because I just kind of found like you have like three or four or five different sources trying to give you the same bit of information, all taking slightly different approaches. So it's kind of like a Venn diagram for me, somewhere where they meet in the middle, where the concepts from all those different sources start to overlap. That's where I could more easily pick out, like, okay, this is the important parts. So those were two things that was like that stood out to me, like why I think that this is definitely a good choice. Just from my my first reactions, I guess you could say. And Preacher, how's it going? I'm doing good. Uh, yeah, I'm doing good. As long as I'm getting my 100 days in, that's that's pretty much where that's pretty much the goal right now. But how's it going for you? I saw you checked in the channel too. I'm gonna check in Discord after I get done today. I have one more palm, so I'm gonna go for my second palm. Day two, let's get it. Yep, 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 yep.
And then use that to create an image classifier. So you can see with some creativity, there's a lot of things you can do with images.
Oh, and right now, I don't know. I feel
This
like Preacher, you probably like this. Right now, he's talking about how you can use image classification techniques, image recognition techniques for um other types of problems besides images. So he showed this one sound.
posted on the forum and said for their project, the more sophisticated the features it can find are. And so you can imagine that trying to code these things by hand would be, you know, insanely difficult, and you wouldn't know even what to encode by hand, right? So what we're going to learn is how neural networks do this automatically, right? But this is the key difference of why we can now do things that previously we just didn't even conceive of as possible, because now we don't have to hand code the features we look for. They can all be learned. Now, it's important to recognize we're going to be spending some time learning about building image-based algorithms. And image-based algorithms are not just for images. And in fact, this is going to be a general theme. We're going to show you some foundational techniques, but with creativity, these foundational techniques can be used very widely. So for example, an image recognizer can also be used to classify sounds. So this was an example from one of our students who posted on the forum and said for their project, they would try classifying sounds. And so they basically took sounds and created pictures from their waveforms. And then they used an image recognizer on that. And they got a state-of-the-art result, by the way. Another of our students on the forum said that they did something very similar to take time series and turn them into pictures and then use image classifiers. Another of our students created pictures from mouse movements from users of a computer system. So the clicks became dots and the movements became lines and the speed of the movement became colors, and then use that to create an image classifier. So you can see with some creativity, there's a lot of things you can do with images. There's something else I wanted to point out, which is that as you saw, when we trained a real working bird recognizer image model, we didn't need lots of math. There wasn't any. We didn't need lots of data. We had 200 pictures. We didn't need lots of expensive computers. We just used my laptop. This is generally the case for the vast majority of deep learning that you'll need in real life. There will be some math that pops up during this course, but we will teach it to you as needed, or we'll refer you to external resources as needed. But it'll just be the little bits that you actually need. The myth that deep learning needs lots of data, I think, is mainly passed along by big companies that want to sell you computers to store lots of data and to process it. We find that most real-world projects don't need extraordinary amounts of data at all.
I always
And as
thought
you'll
that was
see,
a pro
there's actually
to
a lot
deep
of
learning, that you
fantastic
don't need as much
places
data.
you can do state-of-the-art work for free nowadays, which is great news. One of the key reasons for this is because of something called transfer learning, which we'll be learning about a lot during this course. And it's something which very few people are aware of the power of. In this course, we'll be using PyTorch. For those of you who are not particularly close to the deep learning world,
have I used
you might have heard
PyTorch?
of TensorFlow.
Obviously, I've used TensorFlow.
You might be surprised to hear that TensorFlow has been dying in popularity in recent years, and PyTorch is actually growing rapidly. And in research repositories, amongst the top papers, TensorFlow is a tiny minority now compared to PyTorch. This is also great research that's come out from Ryan O'Connor. He also discovered that the majority of people that were doing TensorFlow in 2018, researchers, the majority have now shifted to PyTorch. And I mention this because what people use in research is a very strong leading indicator of what's going to happen in industry, because this is where all the new algorithms are going to come out. This is where all the papers are going to be written about. It's going to be increasingly difficult to use TensorFlow. We've been using PyTorch since before it came out, before the initial release, because we knew just from technical fundamentals it was far better. So this course has been using PyTorch for a long time. I will say, however, that PyTorch requires a lot of hairy code for relatively simple things. This is the code required to implement a particular optimizer called AtomW in plain PyTorch. I actually copied this code from the PyTorch repository. So as you can see, there's a lot of it. This gray bit here is the code required to do the same thing with fast.ai. Fast.ai is a library we built on top of PyTorch.
I haven't used
this
fast.ai.
Huge difference is not because PyTorch is bad. It's because PyTorch is designed to be a strong foundation to build things on top of, like fast.ai. So when you use fast.ai, the library, you get access to all the power of PyTorch as well. But you shouldn't be writing all this code if you only need to write this much code, right? The problem of writing lots of code is that that's lots of things to make mistakes with, lots of things to, not have best practices in, lots of things to maintain. In general, we found, particularly with deep learning, less code is better. Particularly with fast.ai, the code you don't write is code that we've basically found kind of best practices for you. So when you use the code that we've provided for you, you'll generally find you get better results. So, so fast.ai has been a really popular library, and it's very widely used in industry, in academia, and in teaching. And as we go through this course, we'll be seeing more and more pure PyTorch as we get deeper and deeper underneath to see exactly how things work. The fast.ai library just won the 2020 Best Paper Award, or the paper about it, in information. So again, you can see it's very well regarded library. Okay, so okay, we're still green.
So this is like.
Good. So you may have noticed
I need to get my Jupyter notebooks working.
That I'm actually running code in these slides. That's because these slides are not in PowerPoint. These slides are in Jupyter Notebook.
Dun, 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 dun.
Jupyter Notebook is the environment in which you will be doing.
Hold on.
Most.
I never knew you could do that. Oh my God, that's a game changer. Am I the only person that didn't know that I could run that I could run my notebooks as slides? Is this Google?
Most of your computing. It's a web-based application
I didn't know that.
which is extremely popular and widely
Mm, mm,
used
mm.
in industry and in academia and in teaching. And is a very, very, very powerful way to experiment and explore and to build. Um, Nowadays, I would say most people, at least most students, um, run Jupyter notebooks not on their own computers, particularly for data science, but on a cloud server, of which there's quite a few. And as I mentioned earlier, if you go to course.fast.ai, you can see how to use um, uh, various different cloud servers.
I've been using
One
Colab.
I'm going to show an example of is Kaggle. So Kaggle doesn't just have competitions, but it also has a cloud notebook server. And I've got quite a few examples there. So let me give you a quick example of how we use Jupyter notebooks to 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 build stuff, to experiment, to explore. So on Kaggle, if you start with somebody else's notebook, so why don't you start with this one, Jupyter Notebook 101. If it's your own notebook, you'll see a button called Edit. If it's somebody else's, that button will say Copy and Edit. If you use somebody's notebook that you like, make sure you click the upvote button to encourage them and to help other people find it before you go ahead and copy and edit.
Okay, let's do
And once we're in
this.
edit mode, we can now use this notebook. And to use it,
Kaggle.
we can type in any arbitrary expression in
Can I get a
Python
link to
and click
his?
run. And the very first time we do that, it
Okay,
says
here's.
session is starting. It's basically launching a virtual computer for us to run our code.
We have a
This
page
is
to
all
help
free.
you get going with Kaggle. Click here.
In a sense, it's like the world's most powerful calculator. It's a calculator where
Okay, so for me, when it comes to using notebooks, I don't always run every cell. Like I usually run on one cell at a time. Um, and rerun them if I need to. But when it comes to teaching, I never use the slide version or the slide format before. I didn't know that was a thing. So let me see. Because like, did I pin it? Yeah. This is these are some of the notebooks I was working on recently when I was doing the machine learning crash course, the Google machine learning crash course. So all of these are notebooks, and I have these in Google Colabs as well. You know what? Let me open my other profile because these live under a different profile. Um, Colab. Mm, 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 mm. See, here's my collabs, right? Or my notebooks in collab. So this is number 4, example number 4, which is right here. But like I said, I didn't. So like here's a block. That's comments. That's editor. Mirror cell in a tab. Delete a cell. More actions. I have to figure out how that works because it might just be if I was running like the notebooks, the Jupyter notebook server directly, that I would be able to see command palette, terminal, view. It's to me, this is definitely one of the most powerful tools from a learning and from a teaching perspective. Now, if I hit this, okay, yeah, so I'm just gonna have to see how I can do that because I especially like I said, I teach, so I like I've done notebooks before, but I've never used the slide feature. So I'm pretty sure I already have a Kaggle account. I also have Paperspace. To access the course notebooks on Paperspace, you need to clone this repo. Here, let me just follow along with this part. And it's something weird with my browser. Like, if I try to go into full screen, um, the embedded YouTube videos, like going into full screen, can cause issues if you also put your window in full screen. So I don't know what the heck that's all about, but that's definitely a thing that I have been struggling with before. So, anyways, oh
Welcome to
no. Well, I guess I could skip
technically
ahead.
posted on the forum and said for see exactly how things work and to do the same thing. So let me give you a quick example. So let me give you a quick example of how we use Jupyter notebooks to 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 build stuff, to experiment, to explore. So on Kaggle, if you start with somebody else's notebook, so why don't you start with this one, Jupyter Notebook 101.
I'm about to have fun with this. .com/code/J Howard, I think. um, I could be tripping, but I didn't see where they linked to this notebook directly. And then Jupyter dash notebook dash 101. And then let me sign in. Can I sign in with? Mm, I'm pretty sure I already have Kaggle. It's probably not attached to the email I would like for it to be attached to, but meh. This is my Kaggle, my profile. Joined 2 years ago. Never did not a damn thing. Well, I think I did. I have played around a little bit, but not as much as I should have. So let's do this. And then put this on this tab and then do this. Oh, split screen. This is like literally the only thing that I feel like Windows does better than Mac. Split screen life. Um, hmm, Command 0. Okay.
If it's your own notebook, you'll see a button called Edit. If it's somebody else's, that button will say Copy and Edit. If you use somebody's notebook that you like, make sure you click the upvote button to encourage them and to help other people find it before you go ahead and copy and edit. And once we're in edit mode, we can now use this notebook. And to use it, we can type in any arbitrary expression in Python and click Run. And the very first time we do that, it says session is starting. It's basically launching a virtual computer for us to run our code. This is all free. In a sense, it's like the world's most powerful calculator.
Right. So I go
It's a
here and this
calculator
is
where
the
you have
first cell. So
all
I can
of
hit
the
play
capabilities
and
of
it'll
the
run the
world's,
code
I
that's
think, most
inside of
popular
this
programming
cell.
language. Certainly it and JavaScript would be the top two, directly at your disposal. So Python does know how to do 1 plus 1, and so you can see here it spits out the answer. I hate clicking. I always use keyboard shortcuts. So instead of clicking this little arrow, you just press Shift Enter to do the same thing. But as you can see, there's
And
not
then
just
there's my output
calculations
right
here.
there.
There's also prose. And so Jupyter Notebooks are great for explaining to you the version of yourself in 6 months' time, what on earth you are doing, or to your co-workers, or to people in the open source community, or to people you're blogging for, etc. And so you just type pros. And as you can see, when we create a new cell, you can create a code cell, which is a cell that lets you type calculations, or a markdown cell, which is a cell that lets you create pros.
The fact that he keeps saying
And the
pros is
pros
so funny
uses
to me.
formatting in a little
It's
mini
so
language called
formal.
Markdown. There's so many tutorials around, I won't explain it to you. But it lets you do things like links and so forth. So I'll let you follow through the tutorial in your own time because it really explains to you what to do. One thing to point out is that sometimes you'll see me use cells with an exclamation mark at the start. That's not Python. That's a bash shell command. Okay, so that's what the exclamation mark means. As you can see, you can put images into notebooks. And so the image I popped in here was the one showing that Jupyter won the 2017 Software System Award, which is pretty much the biggest award there is for this kind of software.
They have corgi mode.
Okay, so that's
there
the basic
go.
idea of how we use notebooks. So let's have a look at how we do our bird or not bird model. One thing I always like to do when I'm using something like Colab or Kaggle, cloud platforms that I'm not controlling, is make sure that I'm using the most recent version of any software. So my first cell here is exclamation mark pip install -u, that means upgrade, Q for quiet, fast.ai. So that makes sure that we have the latest version of fast.ai. And if you always have that at the start of your notebooks, you're never going to have those awkward forum threads where you say, why isn't this working? And somebody says to you, oh, you're using an old version of some software. So you'll see here, this notebook is the exact thing that I was showing you at the start of this lesson. So if you haven't done much Python, you might be surprised about how little code there is here. And so Python is a concise but not too concise language. You'll see that there's less boilerplate than some other languages you might be familiar with. And I'm also taking advantage of a lot of libraries. So fast.ai provides a lot of convenient things for you. So I forgot to import. So to use a external library, we use import to import a symbol from a library. Fast.ai has a lot of libraries we provide. They generally start with fast something. So for example, to make it easy to download a URL, fast download has download URL. To make it easy to create a thumbnail, we have image to thumb, and so forth. I always like to view, as I'm building a model, my data at every step. So that's why I first of all grab one bird, and then I grab one forest photo, and I look at them to make sure they look reasonable. And once I think, okay, they look okay, then I go ahead and download. And so you can see fast.ai has a download images where you just provide a list of URLs. So that's how easy it is. And it does that in parallel. So it does that, surprisingly quickly. One other fast.ai thing I'm using here is resize images. You generally will find that for computer vision algorithms, you don't need particularly big images. So I'm resizing these to a maximum side length of 400 because it's actually much faster. Because GPUs are so quick, for big images, most of the time can be taken up just opening it. The neural net itself often takes less time. So that's another good reason to make them smaller. Okay. So the main thing I wanted to tell you about was this data block command. So the data block is the key thing that you're going to want to get familiar with as deep learning practitioners at the start of your journey, because the main thing you're going to be trying to figure out is, how do I get this data into my model? Now,
The
that might
versions are
surprise you.
all
We
jacked
might be
up.
thinking we should be spending all of our time talking about
Okay.
neural network architectures and matrix multiplication and gradients and stuff like that. The truth is, very little of that comes up in practice. And the reason is that at this point, the deep learningist community has found a reasonably small number of types of model that work for nearly all the main applications you'll need. And fast.ai will create the right type of model for you the vast majority of the time. So all of that stuff about tweaking neural network architectures and stuff, I mean, we'll get to it eventually in this course, but you might be surprised to discover that it almost never comes up. Kind of like if you ever did like a computer science course or something and they spent all this time on the details of compilers and operating systems, and then you get to the real world and you never use it again. So this course is called Practical Deep Learning, and so we're going to focus on the stuff that is practically important. Okay, so our images are finished downloading, and 2 of them were broken, so we just deleted them. Another thing you'll note, by the way, if you're a keen software engineer, is I tend to use a lot of functional style in my programs. I find for kind of the kind of work I do that a functional style works very well. If you're, a lot of people in Python are less familiar with that. It's more, maybe comes more from other things. So yeah, that's why you'll see me using stuff like map and stuff quite a lot. All right, so a data block is the key thing you need to know about if you're going to know how to use different kinds of data sets. And so these are all of the things basically that you'll be providing. And so what we did when we designed the data block was we actually looked and said, okay, over hundreds of projects, what are all the things that change from project to project to get the data into the right shape? And we realized we could basically split it down into these 5 things. So the first thing that we tell fast.ai is, what kind of input do we have? And so there are lots of blocks in fast.ai for different kinds of input. So we said, the input is an image. What kind of output is there? What kind of label? The output's a category. So that means it's one of a number of possibilities. So that's enough for fast.ai to know what kind of model to build for you. So what are the items in this model? What am I actually going to be looking at to train from? This is a function. In fact, you might have noticed, if you were looking carefully, that we use this function here. It's a function which returns a list of all of the image files in a path based on extension. So every time it's going to try and find out what things to train from, it's going to use that function, which in this case will get a list of image files. Now, something we'll talk about shortly is that it's critical that you put aside some data for testing the accuracy of your model, and that's called a validation set. It's so critical that fast.ai won't let you train a model without one. So you actually have to tell it how to create a validation set, how to set aside some data. And in this case, we say randomly set aside 20% of the data. Okay. Next question then you have to tell fast.ai is, how do we know the correct label of a photo? How do we know if it's a bird photo or a forest photo? And this is another function. And this function simply returns the parent folder of a path. And so in this case, we saved our images into either forest or bird. So that's where the labels are going to come from. And then finally, most computer vision architectures need all of your inputs as you train to be the same size. So item transforms
Matrix math.
are all of the bits of code that are going to run on every item, on every image in this case. And we're saying, okay, we want you to resize each of them to being 192 by 192 pixels. There's two ways you can resize. You can either crop out a piece in the middle, or you can squish it. And so we're saying squish it. So that's the data block. That's all that you need. And from there, we create an important class called data loaders. Data loaders are the things that actually PyTorch iterates through to grab a bunch of your data at a time. The way it can do it so fast is by using a GPU, which is something that can do thousands of things at the same time. And that means it needs thousands of things to do at the same time. So a data loader will feed the training algorithm with a bunch of your images at once. In fact, we don't call it a bunch, we call it a batch or a mini batch. And so when we say show batch, that's actually a very specific word in deep learning. It's saying show me an example of a batch of data that you would be passing into the model. And so you can see show batch tells you two things: the input,
So here's my batch,
which is the picture, and the label. And remember, the label came by calling that function. So when you come to building your own models, you'll be wanting to know what kind of splitters are there and what kinds of labeling functions are there and so forth. Whoops, wrong button. You'll be wanting to know what kind of labeling functions are there and what kind of splitters are there and so forth. And so docs.fast.ai is where you go to get that information. Often the best place to go is the tutorials. So for example, here's a whole data block tutorial. And there's lots and lots of examples. So hopefully you can start out by finding something that's similar to what you want to do and see how we did it. But then, of course, there's also the underlying API information. So here's data blocks. Okay. How are we doing? Still doing good. All right.
I'm gonna let him finish this, and then
So at the end of all this, we've got an object called DLs that stand for data loaders. And that contains iterators that PyTorch can run through to grab batches of randomly split out training images to train the model with and validation images to test the model with. So now we need a model. The critical concept here in fast.ai is called a learner. A learner is something which combines a model, that is the actual neural network function we'll be training, and the data we use to train it with. And that's why you have to pass in two things: the data, which is the data loaders object, and a model. And so the model is going to be the actual neural network function that you want to pass in. And as I said, there's a relatively small number that basically work for the vast majority of things you do. If you pass in just a bare symbol like this, it's going to be one of fast.ai's built-in models. But what's particularly interesting is that we integrate a wonderful library by Ross Whiteman called TIM, the PyTorch image models, which is the largest collection of computer vision models in the world. And at this point, fast.ai is the first and only framework to integrate this. So you can use any one of the PyTorch image models. One of our students, Amanda Mora, was kind enough to create this fantastic documentation where you can find out all about the different models. And if we click on here, you can get lots and lots of information about all the different models that Ross has provided. Having said that, the model family called ResNet are probably going to be fine for nearly all the things you want to do. But it is fun to try different models out. So you can type in any string here to use any one of those other models. Okay, so if we run that, let's see what happens. Okay, so this is interesting. So when I ran this, so remember on Kaggle, it's creating a new virtual computer for us. So it doesn't really have anything ready to go. So when I ran this, the first thing it did was it said downloading resnet18.pth.
Wait, did
What's
I?
that? Well, the reason we
Yeah, I
can
ran
do
that
this so
already.
fast is because somebody else has already trained this model to recognize over 1 million images of over 1,000 different types, something called the ImageNet dataset. And they then made those weights available, those parameters available on the internet for anybody to download. By default, on fast.ai, when you ask for a model, we will download those weights for you so that you don't start with a random network that can't do anything. You actually start with a network that can do an awful lot. And so then something that fast.ai has that's unique is this fine-tune method, which what it does is it takes those pre-trained weights we downloaded for you and it adjusts them in a really carefully controlled way to just teach the model the differences between your data set and what it was originally trained for. That's called fine-tuning, hence the name. So that's why you'll see this downloading happen first. And so as you can see at the end of it, this is the error rate here. After a few seconds, it's 100% accurate. So we now have a learner, and this learner has started with a pre-trained model that's been fine-tuned for the purpose of recognizing bird pictures from forest pictures. So you can now call .predict on it. And .predict, you pass in an image. And so this is how you would then deploy your model. So in the code you have, whatever it needs to do, so in this particular case, this person had some reason that he needs the app to check whether they're in a national park and whether it's a photo of a bird. So at the bit where they need to know if it's a photo of a bird, it would just call this one line of code, learn.predict. And so that's going to return whether it's a bird or not as a string, whether it's a bird or not as an integer, and the probability that it's a non-bird or a bird. And so that's
I
why
don't
we
know
can
how to
print
do.
these
I don't
things
know
out.
what I'm doing.
Okay, so that's how we can create a computer vision model.
Put this here.
What about other kinds of models? Right, there's a lot more in the world than just computer vision. A lot more than just image recognition. Well, even within computer vision, there's a lot more than just image recognition. For example, there's segmentation. So segmentation, maybe the best way to explain segmentation is to show you the result of this model. Segmentation is where we take photos, in this case of road scenes, and we color in every pixel according to what is it. So in this case, we've got brown as cars, blue is fences, I guess, red is buildings, or brown. And so on the left here are some photos that somebody has already gone through and classified every pixel of every one of these images according to what that pixel is a pixel of. And then on the right is what our model
Oh no!
is
Oh no! Oh
guessing.
no! Oh no! Oh no!
And as you can see, it's getting a lot of the pixels correct, and some of them it's getting wrong. It's actually amazing how many it's getting correct because this particular model,
I'm bad for this.
I trained in about 20 seconds using a tiny amount of data.
I just
So,
want my
again, like you would
commit. I
think
want
this
my
would be a
commit for today.
particularly
Because it's like
challenging
11:59.
problem to solve.
Technically that commit is
But it took
timestamps
about 20
now.
seconds of training to solve it. Not amazingly well, but pretty well. If I'd trained it for another 2 minutes, it'd probably be close to perfect. So this is called segmentation. Now you'll see that there's very, very little data required and very little code required. And the steps are actually going to look quite familiar. In fact, in this case, we're using an even simpler approach. Earlier on, we used data blocks. Data blocks are a kind of intermediate level, very flexible approach that you can take to handling almost any kind of data. But for the kinds of data that occur a lot, you can use these special data loaders classes, which kind of lets you use even less code. So in this case, to create data loaders for segmentation, you can just say, okay, I'm going to pass you in a function for labeling. And you can see here it's got pretty similar things that we pass in to what we passed in for data blocks before. So our file names is get image files again, and then our label function is something that grabs this path, and the codes. So the labels for the segmentation. Oh, sorry, the codes. So like, what does each code mean is going to be this text file. But you can see the basic information we're providing is very, very similar, regardless of whether we're doing segmentation or object recognition. And then the next steps are pretty much the same. We create a learner. For segmentation, we create something called a unit learner, which we'll learn about later. And then again, we call fine tune. So that is it. And that's how we create a segmentation model. What about stepping away from computer vision? So perhaps the most widely used kind of model used in industry is tabular analysis. So taking things like spreadsheets and database tables and trying to predict columns of those.
That's like a common
so in tabular
first problem
analysis,
to attempt.
It really looks very similar to what we've seen already. We grab some data, and you'll see when I call this untar data, this is the thing in fast.ai that downloads some data and decompresses it for you. And there's a whole lot of URLs provided by fast.ai for all the kind of common data sets that you might want to use, all the ones that are in the book, or lots of data sets that are kind of widely used in learning and research. So that makes life nice and easy for you. So again, we're going to create data loaders, but this time it's tabular data loaders. But we provide pretty similar kind of information to what we have before. Couple of new things. We have to tell it which of the columns are categorical, so they can only take one of a few values, and which ones are continuous, so they can take basically any real number. And then again, we can use the exact same show batch that we've seen before to see the data. And so fast.ai uses a lot of something called type dispatch, which is a system that's particularly popular in a language called Julia, to basically automatically do the right thing for your data, regardless of what kind of data it is. So if you call show batch on something, you should get back something useful regardless of what kind of information you provided. So for a table, it shows you the information in that table. This particular data set is a data set of whether people have less than $50,000 or more than $50,000 in salary for different districts based on demographic information in each district. So to build a model for that data loaders, we do, as always, something underscore learner. In this case, it's a tabular learner. Now this time we don't say fine tune, we say fit, specifically fit one cycle. That's because for tabular models, there's not generally going to be a pre-trained model that already does something like what you want, because every table of data is very different. Whereas pictures often have a similar theme. They're all pictures. They all have the same kind of general idea of what pictures are. So that's why it generally doesn't make too much sense to fine-tune a tabular model. So instead you just fit. So there is one difference there. I'll show another example. Okay, so collaborative filtering. Collaborative filtering is the basis of most recommendation systems today. It's a system where we basically take data set that says which users liked which products or which users used which products. And then we use that to guess what other products those users might like based on finding similar users and what those similar users liked. The interesting thing about collaborative filtering is that when we say similar users, we're not referring to similar demographically, but similar in the sense of people who liked the same kinds of products. So, for example, if you use any of the music systems like Spotify or Apple Music or whatever, it'll ask you first, like, what's a few pieces of music you like? And you tell it, and then it says, okay, well, maybe let's start playing this music for you. And that's how it works. It uses collaborative filtering. So we can create a collaborative filtering data loaders in exactly the same way that we're used to, by downloading and decompressing some data, create our collab data loaders. In this case, we can just say from CSV and pass in a CSV. And this is what collaborative filtering data looks like. It's going to have, generally speaking, a user ID, some kind of product ID, in this case a movie, and a rating. So in this case, this user gave this movie a rating of 3.5 out of 5. And so again, you can see show batch, right? So use show batch, you should get back some useful visualization of your data, regardless of what kind of data it is. And so again, we create a learner. This time it's a collaborative filtering learner, and you pass in your data. In this case, we give it one extra piece of information, which is, because this is not predicting a category, but it's predicting a real number, we tell it what's the possible range. The actual range is 1 to 5, but for reasons you'll learn about later, it's a good idea to actually go from a little bit lower than the possible minimum to a little bit higher. So that's why I say 0.5 to 5.5. And then fine tune. Now, again, we don't really need to fine tune here because there's not really such a thing as a pre-trained collaborative filtering model. We could just say fit or fit one cycle, but actually fine tune works fine as well. So after we train it for a while, this here is the mean squared error. So it's basically about, on average, how far off are we for the validation set. And you can see as we train, and it's literally so fast, it's less than a second each epoch, that error goes down and down. And for any kind of fast AI model, you can, and for any kind of fast AI model, you can always call show results and get something sensible. So in this case, it's going to show a few examples of users and movies. Here's the actual rating that user gave that movie, and here's the rating that the model predicted. Okay, so apparently a lot of people on the forum are asking how I'm turning this notebook into a presentation. So I'll be delighted to show you, because I'm very
he's
pleased
gonna
that these
tell it.
people
Okay,
made this
good.
thing for
Because
free
this
for
is
us to use. It's called Rise. All I do is, it's a notebook extension. And in your notebook, it gives you an extra little
Oh, okay. So
thing
I
on the
knew I
side
didn't
where
make
you
that
say
up.
which
I'm like,
things
I
are
never
slides
seen
or
that
which things are
before.
fragments. And a fragment just means, so this is a slide that's a fragment. So if I do that, you'll see it starts with a slide and then the fragment gets added in. Yeah, that's about all there is to it, actually. It's pretty great, and it's very well documented. I'll just mention, like,
It was called Rise.
what do I make with Jupyter Notebooks? Thing on the side where you say which things are slides or which things are fragments. Thing on the side where
Okay, how many times it's going?
Now, again, we don't really need to fine tune here because there's not really such a thing on the side where you say which
That's funny.
thing on the side. Thing on the side.
Oh my god! I swear I'm rewinding it.
Thing
Okay.
on the side where you say
It's
which
just
things
gonna
are
keep
slides,
showing me
which
the
things-
same part. Oh, here it is. How to turn your notebook. How to turn your notebook. Can I go back here? Back a little bit more. Okay. Let's just go there.
And in your notebook, it gives you an extra little thing on the side where you say which things are slides or which things are fragments. And a fragment just means, so this is a slide that's a fragment.
Damn it.
So if I
still didn't go back far enough.
do that, you'll see it
It was like, mm, grr, this far back enough.
What do I make with Jupyter notebooks?
Hmm,
Um,
that's crazy. The heck? Anyways, I'm gonna have to find that extension because that
which is
is extremely
quite
interesting to
familiar.
me.
In fact, in this case, we're using an
Training
even simpler
models.
approach. Earlier on, we used data blocks. Data blocks are a kind of thing on the side where you say which. So after we train it for a while,
Okay.
this here is the mean squared error. So it's basically about on average, how far off are we for the validation set. And you can see as we train, and it's literally so fast, it's less than a second each epoch. That error goes down and down.
Y'all see, I'm real committed to getting
And for
this.
any kind of fast AI model, you can, and for any kind of fast AI model, you can always call show results and get something sensible. So in this case, it's going to show a few examples of users and movies. Here's the actual rating that user gave that movie, and here's the rating that the model predicted. Okay, so apparently a lot of people on the forum are asking how I'm turning this notebook into a presentation.
Yeah, see, I know I
So
wouldn't
I'll
be
be
the only
delighted to
person
show
to
you because I'm very
be
pleased that these
obsessed with
people made
something
this
like
thing
that.
for free for us to use. It's called Rise. Um, and
Rise.readthedocs.io. Uh, right. Okay. Escape. Doo, doo, doo. Rise.read the docs. Okay. Here y'all go. I'll probably post this somewhere in Discord. I don't know where it should belong, but this is like the single most useful thing I have seen in the past year. And that counts actually discovering my bestie Chat GPT. So I have to try to yeah, I have to try to get this working. Oh, reveal, of course. Of course. So, I was gonna say this reminds me of a tool that I use a lot, and we use it in the organization that we that I teach for and work with. It's called Reveal JS. So with Reveal, whenever let me see, like girl develop it .github.io GDI Python. So what we would do is we have Reveal is basically like a front end framework that lets you render slides in the browser. So for example, let's see, Python 1. Let's do intro Python. So here's my intro Python class for Girl Develop It. So you can see like the little slide icon down at the bottom. You can click through the slides. Um, you can also like hit escape and you can see like a blown up version of them. And you can nest slides as well. So like that idea that he was saying, like fragments. You can have sub slides, but then fragments would be like this. I'll show you one that has a fragment. I know this slide has a fragment. There's 1, 2, 3, 4, 5 bullet points on this slide, but they don't all display at the same time. When you go over to this slide, it's going to show you each fragment. That's what he was talking about with fragments. It'll show you one section at a time. And if I go to GitHub, I can show y'all what this looks like. So that's immediately what I thought about when I saw that the index page that you saw was just right now I use my index pages as an overview for the classes. So it's this one doesn't have very much in it because it's a 2 hour workshop. It doesn't have like a lot of materials, but for Python 1, where it's usually 4 to 6 sessions long, um in that case the index page would have, you could see like um each lesson and then the corresponding slides that goes to that lesson. So class1.html has all those slides. Yeah. And then another cool thing about this is that you can have code in your slides and you can have syntax highlighting as well. And you can even make these editable so that I could type into these boxes and kind of change them in real time, for demonstration purposes. Um, they're not, it's not enabled right now, but I could enable that as well. So yeah, we usually use this Reveal JS tool, but this is my first time seeing that there was a Python option. So I'm excited. I mean, a Jupyter Notebooks option. So I'm excited about that because there is some work that I want to do for some of our classes that I think the notebooks would suit it a lot more than the traditional like reveal setup. But you can see like every slide is a section. Um and then you can just have normal HTML in here. This is a code block right here. And then the class is how I set the syntax highlighting for with the proper language. And yeah, so going back here, what is Rise? As you know, we love Jupyter and we like Reveal.js too. With Rise, a Jupyter Notebook extension can instantly turn your Jupyter Notebook into a live Reveal.js based presentation. So fucking awesome. Oh my God. Okay, so let me. I want to start this at the very least. Oh, RISE stands for Reveal Jupyter IPython Slideshow Extension. Beautiful, beautiful, beautiful. Okay, so I got that in my toolbox of teaching strategies. Okay. So I'm gonna be finishing up soon, but
All I do
I want to get to a good
is
stopping
it's a
point.
notebook extension. And in your notebook, it gives you an extra little thing on the side where you say which things are slides or which things are fragments. And a fragment just means, so this is a slide that's a fragment. So if I do that, you'll see it starts with a slide and then the fragment gets added in. Yeah, that's about all there is to it, actually. It's pretty great and it's very well documented. I'll just mention, like, what do I make with Jupyter Notebooks? Um, this entire book was written entirely in Jupyter Notebooks. Here are the notebooks. So if you go to the fast.ai Fastbook repo, you can read the whole book. And because it's all in notebooks, every time we say, here's how you create this plot, or here's how you train this model, you can actually create the plot, or you can actually train the model, because it's all notebooks. The entire fast.ai library is actually written in notebooks. So you might be surprised to discover that if you go to fast.ai/fast.ai, that the source code for the entire library is notebooks.
That is really nice.
And so the nice thing about this is that, the source code for the fast.ai library has actual pictures of the actual things that we're building, for example. What else have we done with notebooks? Oh, blogging. I love blogging with notebooks because when I want to explain something, I just write the code and you can just see the outputs and it all just works. Another thing you might be surprised by is all of our tests and continuous integration are also all in notebooks. So every time we change one of our notebooks,
Please show me that.
every time we change one of our notebooks, hundreds of tests get run automatically in parallel. And if there's any issues, we will find out about it. So yeah, notebooks are great. And Rise is a really nice way to do slides in notebooks. All right. So what can deep learning do at present? We're still scratching the tip of the iceberg, even though it's a pretty well hyped, heavily marketed technology at this point. When we started in 2014 or so, not many people were talking about deep learning, and really there was no accessible way to get started with it. There were no pre-trained models you could download. There was just starting to appear some of the first open source software that would run on GPUs. But despite the fact that today there's a lot of people talking about deep learning, we're just scratching the surface. Every time pretty much somebody says to me, I work in domain X and I thought I might try deep learning out to see if it can help. And I see them a few months later and I say, how did it go? They nearly always say, wow, we just broke the state-of-the-art results in our field. When I say these are things that it's currently state-of-the-art for, these are kind of the ones that people have tried so far. But still most things haven't been tried.
Right.
So in NLP, deep learning is the state-of-the-art method in all these kinds of things and a lot more. Computer vision, medicine, biology, recommendation systems,
Machine Gun, thank you for the
games,
prime.
robotics.
I really appreciate it.
I've tried elsewhere.
I think
to
I
make
turned
bigger
my
lists, and I just end up with
notification
pages
sounds
and pages
off.
and pages. So it's generally speaking, if it's something that a human can do reasonably quickly, like look at a Go board and decide if it looks like a good Go board or not, even if it needs to be an expert human, then that's probably something that deep learning will be pretty good at. If it's something that takes a lot of logical thought processes over an extended period of time, particularly if it's not based on much data, maybe not, like who's going to win the next election or something like that. That'd be kind of broadly how I would try to decide, is your thing useful for good for deep learning or not? It's been a long time to get to this point. Yes, deep learning is incredibly powerful now, but it's taken decades of work. This was the first neural network. Remember, neural networks are the basis of deep learning. So this was back in 1957. The basic ideas have not changed much at all. But, we do have things like GPUs now and solid state drives and stuff like that. And of course, much more data just is available now. But this has been decades of really hard work by a lot of people to get to this point. So let's kind of take a step back and talk about like what's going on in these models. And I'm going to describe the basic idea of machine learning largely as it was described by Arthur Samuel in the late 50s when it was invented. And I'm going to kind of do it with these graphs, which, by the way, you might find fun. These graphs are themselves created with Jupyter Notebooks. So these are GraphViz descriptions that are going to get turned into these. So there's a little sneak peek behind the scenes for you.
Coding vibe.
So
Thank you
let's start
for
with kind of a
that
graphic, like, well,
raid.
what does a
Welcome
normal program look
in.
like, right? So in the pre
I'm like
deep
in
learning, machine learning
hardcore
days,
learning
well, you
mode,
know,
so I don't
you
think
still have
I even
inputs and you still
see
have results,
notifications
right?
right now.
And then you code a program in the middle, which is, you know, a bunch of conditionals and loops and setting variables and blah, blah, blah. Okay. A machine learning model doesn't look that different, but the program has been replaced with something called a model. And we don't just have inputs now, we now also have weights, which are also called parameters. And the key thing is this: the model is not anymore a bunch of conditionals and loops and things. It's a mathematical function. In the case of a neural network, it's a mathematical function that takes the inputs, multiplies them together by the weights, by one set of weights, and adds them up. And then it does that again for a second set of weights and adds them up. It does it again for a third set of weights and adds them up, and so forth. It then takes all the negative numbers and replaces them with zeros. And then it takes those as inputs to a next layer. It does the same thing, multiplies them a bunch of times and adds them up. And it does that a few times. And that's called a neural network. Now, the model, therefore, is not going to do anything useful unless these weights are very carefully chosen. And so the way it works is that we actually start out with these weights as being random. So initially, this thing doesn't do anything useful at all. So what we do, the way Arthur Samuel described it back in the late 50s, the inventor of machine learning, is he said, okay, let's take the inputs and the weights, put them through our model. He wasn't talking particularly about neural networks. It's just like whatever model you like. Get the results. And then let's decide how good they are, right?
Loss
So if, for
function.
example, we're trying to decide, is this a picture of a bird? And the model said, which initially is random, says this isn't a bird, and actually it is a bird, we would say, oh, you're wrong. So we then calculate the loss. So the loss is a number that says how good were the results. So that's all pretty straightforward. You know, we could, for example, say, oh, what's the accuracy? We could look at 100 photos and say which percentage of them did it get right. No worries. Now the critical step is this arrow. We need a way of updating the weights, that is coming up with a new set of weights that are a bit better than the previous set. Okay. And by a bit better, we mean it should make the loss get a little bit better. So we've got this number that says how good is our model. And initially it's terrible, right? It's random. We need some mechanism of making a little bit better. If we can just do that one thing, then we just need to iterate this a few times. Because each time we put in some more inputs and put in our weights and get our loss and use it to make it a little bit better, then if we make it a little bit better enough times, eventually it's going to get good. Assuming that our model is flexible enough to represent the thing we want to do. Now, remember what I told you earlier about what a neural network is, which is basically multiplying things together and adding them up and replacing the negatives with zeros. And you do that a few times. That is provably an infinitely flexible function. So it actually turns out that that incredibly simple sequence of steps, if you repeat it a few times and you do enough of them, can solve any computable function. And something like generate an artwork based off somebody's Twitter bio is an example of a computable function, right? Or translate English to Chinese is an example of a computable function. So they're not the kinds of normal functions you do in year 8 math, right? But they are computable functions. And so therefore, if we can just create this step, then, and use the neural network as our model, then we're good to go. In theory, we can solve anything given enough time and enough data. And so that's exactly what we do. And so once we've finished that training procedure, we don't need the loss anymore. And even the weights themselves, we can integrate them kind of into the model, right? We finished changing them, so we can just say that's now fixed. And so once we've done that, we now have something which takes inputs, puts them through a model, and gives us results. It looks exactly like our original idea of a program. And that's why we can do what I described earlier. That is, once we've got that learn.predict for our bird recognizer, we can insert it into any piece of computer code, right? Once we've got a trained model, it's just another piece of code we can call with some inputs and get some outputs. Deploying machine learning models in practice can come with a lot of, little tricky details, but the basic idea in your code is that you're just going to have a line of code that says learn.predict, and then you just fit it in with all the rest of your code
I
in the
haven't done
usual
a
way.
lot of
And this is why,
model
because a trained
deployment,
model
so
is just another thing that maps inputs
I look
to
forward to
results.
doing more of that.
Okay. All right, so as we come to wrap up this first lesson, for those of you that are already familiar with notebooks and Python, this is going to be pretty easy for you. You're just going to be using some stuff that you're already familiar with and some slightly new libraries. For those of you who are
Homework.
not familiar with Python, you're biting into a big thing here. There's obviously a lot you're going to have to learn. And to be clear, I'm not going to be teaching Python in this course, but we do have links to great Python resources in the forum. So check out that thread. Regardless of where you're at, the most important thing is to experiment. And so experimenting could be as simple as just running those Kaggle notebooks that I've shown you, just to see them run. You could try changing things a little bit. I'd really love you to try doing the bird or forest exercise, but come up with something else. Maybe try to use 3 or 4 categories rather than 2. Have a think about something that you think would be fun to try.
Mm.
Depending on where you're at, push yourself a little bit, but not too much. So make sure you get something finished before the next lesson. Most importantly, read chapter 1 of the book.
Mm-hmm.
It's got much the same stuff that we've seen today, but presented in a slightly different way. And then come back to the forums and present what you've done in the Share Your Work Here thread. After the first time we did this in year 1 of the course, we got over 1,000 replies. And of those replies, it's amazing how many of them have ended up turning into new startups, scientific papers, job offers. It's been really cool to watch people's journeys. And some of them are just plain fun, So this person classified different types of Trinidad and Tobago people. So, people do stuff based on where they live and what their interests are. I don't know if this person is particularly interested in zucchini and cucumber, but they made a zucchini and cucumber classifier. I thought this was a really interesting one, classifying satellite imagery into what city it's probably a picture of. Amazingly accurate, actually, 85% with 110 classes. Panama City bus classifier, batik cloth classifier. This one, very practically important, recognizing the state of buildings. We've had quite a few students actually move into disaster resilience based on satellite imagery using exactly this kind of work. We've already actually seen this example, Ethan Sutton, the sound classifier. And I mentioned it was state of the art. He actually checked up the dataset's website and found that he beat the state of the art for that. Elena Harley did tumor normal sequencing. So she was at Human Longevity International. So she actually did 3 different really interesting pieces of cancer work during that first course, if I remember correctly. And I showed you this picture before. What I didn't mention is actually this student, Gleb, was a software developer at Splunk, big NASDAQ listed company. And this student project he did turned into a new patented product at Splunk and a big blog post. And
That's
the whole
cool.
thing turned out to be really cool. It's basically something to identify fraudsters using image recognition with these pictures we discussed. One of our students built this startup called Envision. Anyway, there's been lots and lots of examples. So all of this is to say, have a go at, starting something, create something you think would be fun or interesting, and share it in the forum. If you're a total beginner with Python, then start with something simple, but I think you'll find people very encouraging. And if you've done this a few times before, then try to push yourself a little bit further. And don't forget to look at the quiz questions at the end of the book and see if you can answer them all correctly.
Oh no, quiz.
All right. All right. Thanks everybody so much for coming. Okay. Thanks so much for coming, everybody. Bye.
Okay. So, yeah, I like this class a lot. I if I have put the link in chat. Here I'll put oh, my music actually my music actually ended while we were listening to that, but I did put the links in the chat. So this is course.fast.ai, and this has been recommended to me quite a few times in the past couple of months. And then I decided to take this class because also because it was recommended as a prerequisite for the NLP class that I want to do, that Hugging Face has. So I pretty much took these recommendations, which is I did want to do something with deep learning AI. I didn't know if I wanted to start with a specialization with them. And that was an option to start there as well, but I felt like it was more ideal for me to do this practical deep learning for coders, just kind of get my feet wet and build some stuff, establish some knowledge, like like you said, they take a top down approach. So I do technically have to take a calculus class like in the next month or so. That's um part of it is foundational, part of it is just because I'm going back to school, so I have to have a calculus credit that's within 5 years, which it's been a long time since I took calculus. So one thing that they mentioned is that they would not, like, they'll go into a lot of the math, but they're not starting out with the math, but they are going to cover some math like calculus, linear algebra, stuff like that. So um I think it's good to kind of, like I said, just get that practical experience from the Fast AI workshop. Then after that, I'm going to move to the NLP course on Hugging Face, because I really am interested in like understanding and learning about like the different transformer approaches. Hugging Face has a lot of they have transformers integrated into the library. And then once I finish this, I do plan on going to probably the NLP specialization for deep learning AI. So that's the main things that I'm trying to focus on, instead of picking and choosing different things here and there. So I'm going to build some projects along the way. Now I do have a sentiment analysis project I want to do for the live stream chats. So that's one. Hugging Face isn't this such a great name? Also, they literally always have the freaking hugging emoji. So that's what makes it even better to me. um but yeah, so I want to do, let me see, do I have Notion open right now? Probably not, because my computer was tripping last night. I closed everything, okay? I had to. And I did already do my little log for today, so I'm gonna close this one for now before it goes crazy on me. Okay, here we go. So here's one project, the mood bot. So that's sentiment analysis. I should be able to do something related to this for sure. I just don't know exactly where it might fit in. The other project that is my bigger project is building the stream partner, AI stream partner. So um, I have been brainstorming just the tiniest details of some things that I can play around with. So I have a couple ideas. Um, Now they gave homework, so what I think my plan is the next thing that I should do, since I watched the whole video for lesson one, and they actually said that originally this material was like 7 weeks. So there are 7 lessons, one for each week. I think he said 7 weeks. So if I already looked at watched the entire lesson one, this week I need to read through chapter one of the book. I do have the book. I have the book forked and cloned as well. So, chapter one of the book, and then I want to build some type of example notebook. Maybe I'll do some other image classification and just try to apply it to something other than traditional images. Or I might do something weird, like, I don't know, I just had this random thought, like, uh um I might take like images of videos, like YouTube videos, say like YouTube videos and like Twitch streamers, like uh just random screenshots of images, and see if I can train something that can say whether it's a YouTuber or a Twitch streamer, just purely based off the aesthetics. Because I strongly believe that you can kind of, especially me being a person that I stream a lot, but also like I literally watch YouTube 24/7. I feel like visually you can definitely tell the difference. So I'm going. So that's one. That's just one little like small image classifier thing I can do that can be fun. So I think I want to try that. And I've been taking like writing myself little sticky notes because I left my notebook in the living room. Um, but I wrote it here. YouTuber versus Twitch streamer image classifier, because I can take that Kaggle notebook that I this example one here, and instead of doing the bird predictions, I could do something like that. So I don't know, I think that would be fun. That would be a good little project to start with. um Trying to think if there's anything else I need to give myself. Now the real question is, how will I keep track of what I said I was gonna do for the next day? um I've been trying to be good with my tracking. I think I want to set up something for 100 days, just so, well, excuse me, I can make my life a little bit easier. But yeah, so I don't know. This is like way later than I was trying to be up, but that's okay because um, I really would be proud of myself if I get my 100 days consecutively, and also don't miss a stream. And it's my birthday week, so my birthday is on Sunday. I don't even know what I'm doing for my birthday, but I will be here for a stream one way or another. So yeah, I'm going to put the here, put Discord back in the chat. So there is a few people. Oh, I should check in. Let me check in on Discord too. Um, some people have joined the 100 Days of Code channel, which is, no pressure at all. But for me, like accountability and having accountability buddies and, just having a place where everybody kind of has a shared goal, that helps me out a lot. I thought I saw my cat. Okay. But yeah, that helps me out a lot. So, yep, here's our day 2. Let's see. I finished the first lesson of Okay. So I officially did. So yeah, I appreciate everybody that is, you know, participating with 100 days, cuz I don't know, emotional support, right? Uh that's important to me. So I highly recommend this if you are interested. There's other practical, like, you know, machine learning or deep learning for developers options out there. This is not the only one, but I really like how up to date this material is, especially since a lot of things have been moving so fast recently. They did this was recorded in 2022. Let me see really quick because I have the playlist saved on YouTube as well. Look, it's me. I'm live and I'm live. I'm live and I can see myself. Um yeah, so I don't know, y'all. Y'all know I'm a fan of streaming on Twitch. I just feel like it's such a silo to be in. So this 100 days, I have been doing the Thursday podcasts have all been live streamed to YouTube channels, but besides that, I have not ever done my live coding on YouTube. So now my YouTube, um, all the live streams for this series will also be on YouTube. So once they disappear from Twitch, they'll still live on into the future. I came here. That moment when your brain just turns off. Dang it! What was I looking for? That's crazy. Was this something related to my channel? Probably. Or this is the music we're listening to right now, by the way. Oh, it was a playlist that I saved. Let's go. It's the Fast AI playlist. Oh, here it is. Practical deep learning for coders. I'm gonna make this one. I'm gonna put this one on the channel so you can see it in case you want to see how I'm following. But Yeah, I'll put it on the channel page. But yeah, this one is it was recorded 9 months ago. So not bad actually. Um cause like this was they did this one after Dolly, and I don't know. At some point they probably should talk about like GPT and stuff like that, because this is towards the end of the year, honestly. It's in the latter half of the year. So that's a big, big, big bonus to me that the material is so up to date with a lot of the new things. Oh, last updated on July 28th. Let's see. Maybe I should subscribe to Jeremy's channel. And then y'all, another channel I highly recommend for the AI machine learning is IBM. A lot of people are sleeping on IBM. Oh, Mass Mother, thank you for thank you for the reminder. Also welcome. A lot of people are sleeping on IBM, the IBM technology channel right now, y'all. Don't do that. The channel is so good because the thing I like about this channel is there is a lot of high, what I want to call it, like big tech, um like fundamental concepts that are very easily explained. They have a lot of series. That's very organized. Like I don't know. I think they're doing a really good job with a lot of this stuff. So, um, also I'm super jealous of them. They got the whole like glass whiteboard, where you like write behind the board, but then it's just so sweet. I don't know. That's like the teacher in me. That's like I wish I had one of those. But they have an AI essentials playlist. That's not what I wanted to do.
Hey, what's up, everyone? My name is Love Agarwal, and I'm a data platform.
Here, let me go. AI essentials. Oh, here we go. Okay. Um, so this is a good one. Like you can see, I've been watching stuff about Transformers. Because that's like obviously the big thing right now. Like GPT, all the BERT, all those models are based off like the Transformer architecture, and that is new to me because LSTM, or long short term memory, that was what was kind of like the new hotness, I guess you could say, when I first started learning about deep learning. So I've been watching a lot more videos about the some of the newer architectures and whatnot. But I think that, like I said, they have a really really good series, and I was already following IBM because of some of the other series that they cover that I think a lot of people, might not necessarily get exposure to. I learned a lot of these things like on the job, which is not exactly the way that I would have preferred it. I would have preferred having like some of these resources available. But yeah, so I recommend that channel. And then, there's a lot of other stuff going on, but I recommend Hugging Face for sure. And I'm going to start taking a look at how some of the open source models are doing and just kind of experimenting there. So that's just what I'm into right now. So yeah, I don't know. It's only day two, but the nighttime streams are working out okay right now. So, the only issue is like I really have to wait till I put baby boy down. So yeah, we'll see. But he's getting really good with his bedtime. So usually he sleep around 9:30. Um, but I will be doing like my daytime streams as well. I'm just kind of trying to find a good flow at the moment. So yeah, um, I have my goals for the rest of the week. So tomorrow, since like I said, I already went through all this material, I don't know. I might order that book. even though they have the digital version of it. Another book I have, I think my book is in the windowsill. I have the AI and ML for devs from, let me see, it's probably in Discord. It's also from O'Reilly. AI ML channel, maybe. See, here's the Learning Transformers video. This is the whole playlist actually. Oh, this is the playlist that I've been making actually. This is like a combination of different Transformer videos, but you saw that IBM videos in there. Oh, this is the other one, y'all. I wanted to share this one. The MIT Intro to Deep Learning. They run this. I want to say they run this at least once a year right now. And whenever they do run it, they put all of the newest videos in the current playlist. So this is the other one. That one is in Discord too, so it's already linked. But so you can see like their 2022 course was up. Actually, basically all of the previous years are still in the same playlist. So they've been doing it since 2018. But this is intro to deeplearning.com. So they are, this one again, I think it has the benefit of being very recent, very up to date, because they are running this now. They're almost done with this run of the class. Lecture 9. Yeah, so this week, I think this week is the last lecture. So that's the other one I recommend if you want to look more at like the deep learning stuff and you want something that's super recent. That's what's been really important to me. So recommend those for sure. So I'll be working on my reading through the book and doing my project this week, and I will post about it. I think I'll make a blog for sure for myself, but I think I might post on the Fast AI forum as well and try to participate. I've been trying to do better with LinkedIn as well, so I might just put a little bit of stuff up there. But yeah, so let's see, how's everything going on Twitch now? Again, this is not my first time. This is not my first time doing 100 days of code, but I still have not successfully completed my entire 100 days. So I'm just like, I have no problem trying again. So let's do this. Let's go hang with Coding with Strangers. I'm gonna set a rate for Coding with Strangers. And I appreciate everybody that came in with the rates as well. Thanks again, Coding Vibe. Thanks for the resub from Machine Gun 21K. Yeah, so I appreciate y'all. I'll see y'all tomorrow. Coding with Strangers is a wild man. Okay. We'll see what he's working on today. So here, let me do this because I always miss the raids. I have to like kind of set myself on the channel in the browser so I can raid over with everybody else. And I'm getting my life together, y'all. So every little bit I can do, anything that anybody finds helpful, let me know. Otherwise, I will see y'all. I was gonna say tomorrow, but it's really today, ain't it? I'll see y'all later today. Give coding with strangers some love, everybody. Good night.